Okay guys, so let's start. Today we are going to see further dive into the Kubernetes. So I will be going through the parts and services and everything step by step. So most of we have already covered about till service, like what are parts, basic configuration, basic architecture of the Kubernetes. Now we are going to learn like how parts are connected, like what are labels, selectors, these things are there. So let me tell you, like whenever we create a deployment file, in that file, what happens? Generally, in the labels, give the name, actually name of the pod, what with which it is later to be discovered. So there is a selector in the services file. Selectors inside the selector there is kind of we give the name of the label with which all the traffic will be routed to the on that particular pod via label. So selectors should match exactly the name of the label which is given in the deployment file. So let me show you here. Uh, Here you can see I have a service file via this one. So here you can see it is a kind of service. You just focus on this selector. Like this is the one which routes the uh, traffic to the pod. So here you can see the name is very important. This name of the app is Engine X. There is nothing extra like something extra like maybe hyphen. You can say any name other than the pod which is created. Engineers G or suppose KLE, something like that. And I also have my deployment file. You can see, let me show you that also. So here you can see my deployment file. Uh, okay, here we have in the deployment file. So let me open it. Nginx deployment. Okay, cool. So here you can see the name of the label is here. The label in the template, then metadata, focus on this part. I have the file ready. Okay, let me start from the beginning. Here you can see the version controlling like app slash v1. So this is the v1 app, and then there is it is a kind of deployment. So deployment is like this file basically gives you all the details about what would be the app our Kubernetes pod would be doing. Basically, the configuration, all stuff is here. So here you can see engineer deployment, some metadata, and then there are specifications like script given the replicas is equal to 5. It means like we have to create 5 pods for 5 replicas for our pod. Which pod? Which is Nginx deployment. Okay, so this is the name of the pod, and here you can see the label. This part is very important. Selectors and then templates. So here you can see selectors is given match labels app is equal to Nginx, and here you can see the metadata. The name of the label is Nginx, right? So the inside basically the pod would be deployed, and the name of the app would be Nginx. Okay, and this would be the routing. Basically the service would be this is the selector. So this we will give also in the service, and this should exactly match with the Nginx. What I mean to say is, if we change from the service, you can see there is Nginx DB. I have renamed it. Okay, so earlier, first let me show you what is the current condition. Okay, how parts are running, and let me show that. So here you can see what I have given is minikube service nginx service. So this command is actually gives us the service, right? And this routes to this Nginx welcome page. Yeah, but suppose I I want to change this, right? I want to change the values here, the name of the file. Second, where it is. Okay, this. So suppose not this. It is the deployment file. I don't want to change it. I want to change the services file where it is. Okay, this one. Cool. So now I want to change this. And first of all, daily something I want to change. Okay, I change the label. I change the label in the service file. Now this label Nginx daily. There is no such label mentioned here. Here in the you can see in the template there is no app running with the Nginx hyphen daily. Our pod is running with the name Nginx. So let's see, first of all, let's see the what are the status of our pods. So we need to run the command kubectl get pods hyphen l is equal to Nginx, right? So name cannot be provided when a selector is specified. The same name cannot be provided when a selector is specified. So there is the problem with the space actually with the command. Cool. So here you can see 5 pods are running, 5 replicas actually. One pod with 5 replicas it is running. Uh, Here the 5 replicas. Cool. Now when we will start this uh, here in reply event we have Nginx. You can see the name is already Nginx. Everyone is the Nginx deployment. Okay. Now let's see about the service. The same command, old command we will run. What is the service? So it will say like it is working. It should not work. Okay, cool. I got it. Actually, we have not after the changing these configuration the name actually here. Yeah. This Nginx daily we need to apply this to the we need to restart the service and apply the configurations. Okay, so there would be a configuration command, so we need to use apply command actually. So let me show you this one, kubectl apply hyphen icon this apply hyphen f Nginx service, our service file, then it should be configured. Cool. Here you can see it is configured. Basically we have not created a new service, we have just changed some configurations, so it is saying it is configured. Okay, now let us see about the service. The service should not be there, right? And there should be some error because we do not have any label matching with Nginx daily because there is nothing here in Nginx daily, right? So there is no pod running, so there should be some error because it is not able to route, right? Yeah, you can see it is exiting due to service error, service not available, no running pod for service Nginx service pod. So there is no route, no pod for service Nginx found. You got it? Nginx service it is running, but it is saying there is no pod. Let me change the label here in the deployment file and we will apply the same on the deployment, and then we will see like if this Nginx daily is working here in deployment. Suppose I want to change this label template fn label x label, right? Now let's apply this configuration. So the same command, similar command we need to apply hyphen this, then Nginx hyphen deployment, right? Okay, it is saying deployment is invalid, spec template invalid, Nginx daily selector does not match the template label. You can see the error, like it is saying like it does not match the template labels. So we need to change all the files. I think we need to change the label with selector. Okay. Uh, 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 uh. Okay. Okay. We need to check this selector actually should match here. Right? Now if it is matching, the label is matching, then we can configure it, right? But it is saying the deployment engineer device is invalid, asset invalid, match label app nginx daily, field is immutable. Okay, this field is immutable, we cannot change it. So we cannot change it, then what we can do? We cannot change the selector for now. Actually it is up and running, so I think it is not taking. We need to create from the scratch. So let me go back, like I want to show you, like if there is a mismatch, again service will give error. Now this app and this label both are matching, so there should not be any error. Okay, let's see. Okay, it is saying unchanged because it is unchanged. What is the problem? What I wanted to show you. And then suppose I want to give this thing, then it's still here. Containers name in the next image is in the next, it is not a problem, I think. Suppose what I do is Nginx daily every place. Suppose I want to do this daily and then hyphen daily and every place daily and hyphen daily. Will it again give the same error saying it is unchanged? Or not mutable, something like that. The deployment engine deployment is invalid F selector invalid value. Let me see the error. What is the problem? Why it is immutable? Speaker circuit field is immutable. Okay, it is saying in Kubernetes apps v1 the spec dot selector field is immutable. Once a deployment is created, this means you cannot change which label the deployment uses to find its ports without deleting and recreating values. Oh my god. Basically, we need to delete everything from this script, which I was thinking. So why this happened? You likely try to change the match labels value, which we did. And then is daily in existing deployment currently prevents it because changing the selector would orphan the existing ports as the deployment would no longer recognize them as its own. Auto since we cannot update the field place, we will delete and recreate the deployment. Okay, so we can delete, then again we create server. Now this will temporarily stop the running parts unless we use hyphen cascade is equal to I from the represent existing effects. Okay. So basically we do not, it is immutable, we cannot change for now. Okay, we cannot change, so let it be as it was. Cool. We got our answer. Wait about deployment. So once a deployment, so things to remember is like once a deployment is done, we cannot change the values, basically the selectors and these values. Okay, so let's write it and apply the configuration again. It should be unchanged. Awesome. Now let's see our service file. Service not available. The same error because in the service file we all still have our value has to be daily in the next time, right? So in Nginx we need to do this. Cool. Now this should be running fine. It is happening. Okay, here it should be our service file, not deployments file. Now it is configured. Now we should get our service running. Awesome. Cool. Now let's proceed ahead. So till here we have already done things which we need to know. Everything in Kubernetes is decoupled. Objects do not reference each other directly. They are connected by labels and selectors, which you know, like selectors used for routing the traffic. Okay, this is kind of load balancing. But yeah, selectors route the traffic through the labels. They match the label name, exactly the label name, and then only they connect with the pods. This makes the system flexible and scalable. So locking this deployment manager lifecycle. Replica sets maintain the count of the pods. Pods run on containers. Basically, they run the containers. Service provides stable access. Okay. Stable access means there is a variation in the pods, right? The IP variation in the pods, and every time suppose a pod is created, deleted or destroyed, then a new pod is created. At that time, a new IP is generated. But the service basically it provides a stable IP address. It always connect on the it gives a URL which you can see here. It gives a stable external URL so that any pod which is created they can be contacted. They should not be remained often, like they should not be unreachable. So this is the stable IP which gives it. Otherwise, manually finding those IPs and then accessing them, it is not advisable and it is not a best practice. Labels connect everything. Yeah, labels by label everything is connected. The pods are connected. Now it is more step by step like self-healing demo, load balancing demo, rolling update, replica set data. So we will first let's move to self-healing demo. Like self-healing demo means like when a pod is running, suppose there are different instances of the pods are running. If one instance is down, if one pod is down, then a new pod should be automatically created. This is called self-healing. Like it should be created by on. Let's do it. Okay. So time to break the self-healing. Okay. So what we are trying to prove, like your deployment says we have replica set. Here it is true, but we have 5 pods running, which we saw earlier. Let me show you again. Our pods, this one, right? So we have 5 pods which we are running, and notice same prefix different random suffix. That suffix generated by replica set. So here it is saying about the suffix. Suffix means the number. This number is automatically randomly generated, so it is a random number. But yeah, prefix is same. Okay, this deployment happened. and this is subject, so it is saying the same. Then it is suggesting pick one pod name and run. Okay, we want to delete one pod, so let's delete one pod. Okay, so there is a command kubectl delete pod and then our any pod name. So suppose we want to delete this third pod. Okay, so let's command kubectl delete pod and then our pod name. Okay, so this pod is now deleted. This, remember the name, like this 989x4. Okay, this is deleted. So let's see, now we are having only 4 pods. It is still giving, I think it just has recreated a new pod, because you can see this one is already there, this one is also there, then is the decay, this is also here, and this is also here, but this one is created with a new one. So I think it is already self-filled. It is restarting here, you can say restarts is equal to 1 but it is here 0 restart 17 second. I think it is already self-filled, I cannot show you, but it already created a new pod. Okay, cool, let's see. It is saying immediately run just after this get pod -w. W means watch mode. Okay, so let's see if we can see the watch mode. It is status is already running. You cannot see FNW. Pod was terminating. The new pod appears with a new name. States changes from container creating to running. So these things didn't we were not able to see because it was so fast. So let me delete once again the pod and then immediately run this command. Okay, so let me run. Let me delete this one again. Nginx this one. Okay, delete pod this one. Okay, let me be ready with this command actually, otherwise this time again we will miss. This I have already copied. Okay, and I have deleted. Okay, now just watching. Yeah, here you can see container is creating. Awesome, awesome, we got it. So we are watching now container creating, and then it is suggesting like there would be new name. So it is a new name actually, m8jw9, and then container goes to running status. Let's see when it will go to running status. That is self-healing. Okay, so what actually happened here, you deleted a pod, replica said notices actual replicas, notices actual replicas is equal to 1, desired replicas 2. So in our case it was 5 actually, and total actual replicas should be 4. Replica set creates new pod scheduler assigned. So replica set creates a new pod scheduler assigned it to the node. Okay, to the node. We will know, we will see about nodes also. We have not seen that node. Container pulls image if needed or starts running, no intervention. That's Kubernetes control loop in action. Awesome, awesome. Okay, so let's see this time without the parts watching. Let's see the listing. You can see it is now running. It's been 90 minutes. Okay, cool. So braining question is brainer is like who did the healing, not deployment directly. Flow, we know like deployment then replica sets, the replica control, and then we have replica set is the one enforcing count. Okay, replica set is counting, deployment only manages replica sets. Okay, so Kubernetes constantly runs controllers in the loop. There is controllers I had shown you. Kubernetes architecture. Let me pick any architecture diagram which is cool. Let's see this Kubernetes site. If it has good architecture diagram, or we can choose someone else. What happened? Okay. Cool. Actually, yeah. Now you can see. So here you can see we have the Kubernetes cluster and there is control panel. Here there is control. This not this control manager. There is a controller manager. This controller actually I am talking about. So it is saying this controller. There is a scheduler. There is a etcd file which is key value stored, and then there is a key API server which talks with the nodes. Okay. Here you can see there is an arrow coming to this one. API server is kind of communication point to the control plane. And controller manager, we are going for the controller manager. Here you can see Kubernetes constantly runs controllers in the loops. These controllers which we saw here, these continuously run and they watch, they see what is happening. So it is saying like while true, compare desired state versus actual state. Like if our desired state is 5 and actual state is 5, then we need more. So we need to, if there is a mismatch, which is in our case 5, when we deleted 1 it became 4. So there are 4 replicas and we need one more replica, so it will recompile. Okay, so this pattern is called reconciliation loop. I think we may get in the interviews like what is reconciliation loop. So basically this is the core philosophy of the Kubernetes. Like these controllers, they always run in loop and they check for the replica sets which are what how many numbers of replica sets are right now running. If the desired state is matching, then good. Otherwise, it will reconcile and it will create a new pod. Let's go deeper. Optional but powerful. After deleting a pod, give CTI describe deployment and then is deployment. Let's see what happens here. You can see we are describing our deployment. In Nginx deployment, there is a default namespace. We have not created anyone. And then there are some annotations and the replica set. You can see selectors. You can see labels. We have not given. I think we had given. Okay, let's see. Selectors we have given app is equal to Nginx replicas, file desire, file data, file total, file. So all is good. Strategy type is rolling update. Okay, slowly and means it will move some parts of the traffic. Main rate is seconds. Rolling update state 25% max unavailable, 25% max size. Okay, it will start after that. And pod template we have labels this containers Nginx, image Nginx, port this one, host port 0, environment mounts no nothing, no volumes and then no selector tolerations. Okay, and then there is a conditions type progressing new replicas set available, new replicas available. Okay, old replicas no one, new replicas we have just created which one. Okay, events now. Cool. Now let's see what it is saying. After deleting a pod, if we will run event selection replica set name, look at the events section. Look at the events section. So where is event section? You can see space. Where is events? And then see, okay, this one event section it is none. Okay, replica set name. Replica set name we have already seen. Replica set name where it is new replica set. This is the name, right? Desired versus available replica which we already saw here. Okay, you see history of what happened. So let's delete and then see why we are doing this. Let's delete one part and then we will see again. Let's delete this one again. The third part. Okay, command C. So we want to delete this delete part, which is this one, and then again we need to immediately run our this describe command, right? Just after deleting, before the replica is up and self healing is done. Uh, four available. You can see here four available, one unavailable, right? This is the major change after deletion, and then the old replica 9. This one is created 5 replica. Again, we get the 5 replicas. Uh, so here it should be 5 again. Yeah. So this was the difference. Earlier there was 4 and 1 unavailable, but here you can see it was 4 unavailable, 4 available, 1 unavailable. Now after deletion it was listed. Now after self healing it is already up and running. So unavailable is 0 and all containers are running. So let's get again out of the parts. You can see this is a new one which is running. No, not this one. This one. ZQ725. Cool, cool, cool. Now let's see a real production scenario. If a node crashes in cloud, 5 pods running, 2 die because node died. Because it creates 2 new pods on the other path. No manual restart. That's why Kubernetes replaces traditional VM-based deployments. Okay. It is saying like if a node crashes in a cloud, 5 pods are running, 2 dies because node died. Then what happens? Replica set creates 2 new pods. After deleting the pod, did you see a new pod created? Tell me what happened in the terminal. Next step after this is okay. So it is just we are just we observed these things, right? Did we see any pod? Yes, we saw. Tell me what happened in terminal. Everything was good as expected. Next step after this, we test real load balancing between pods. Uh, first let's go with load balancing. First load balancing, then rolling update. Okay. So now what we are going to do? We are going to see a load balancing between the parts. Okay, between the pods. So right now we have deployment. We have 5 parts. Here it is 2. Service. We have node port, and service selects pods via IP equal to nginx, which is the in the selector style, right? Then let's prove that traffic is displayed across pods. Okay, so this is the command -o void. Let's see what are the pods we are running. So a new thing is like -o, open this -o void. So here till here we were already observing, but now new fields, new columns are there like IP. You can see IP is here 10 to 44.0.1, then different IPs like 9, 10, 11, 12, not 12 but 13, 16, yeah. And node is minikube and nominated node rate line. Okay, these things are not there, but yeah, IP is the new thing. Okay, now let's move ahead. Each pod has a different IP which we saw, like 9, 10, 11, 13, and 16. Step 2. Check service endpoints. Okay, let's see service endpoints which we have seen already. I think this was our service endpoint, right? This was 131.793 something like that. Okay, let's see the services then. Let me run the command. Okay, so your endpoint is deprecated. V1 endpoint is deprecated. V1 okay, you discovery. Okay, we will see later. First, right now, what matters is like the name and then endpoints and then age. So here you can see the IP is 24080, then 11, so 10, 11, 13, and 16. Basically the same thing, I think. 9, 10, 11, 13. So all are listening on port 80, right? Okay, this means service is routing to both ports. So basically our service is routing to all the ports, basically all the five. Three are here plus two more. So all the five ports are being routed. So service is routing on all the endpoints, basically all the ports through load balancing. Okay, now we'll modify each port to return its host name. Run this command to open a shell inside one port. Okay, so it is saying we will modify each port to return its host name. Okay, so let's execute it. Qctl no such file or directory. Actually we are not giving any pod name, so let's select similar the third word again, our favorite one. Now let's see. Okay, so in this folder I think it is executed. There is going to open a shell inside one part. We are inside the pod. You can see if we are in this inside one pod. Okay, right now you can see awesome. I got it. So when we executed this previous this nginx command, we give the path to our basically we entered one of our pod. Here you can see we entered the bash bsh because uh, of the pod. So third pod, we entered inside the third pod. Right now we entered in the pod, third pod. Okay, now we can echo something like this. Okay, let me run this. So we exited this. Okay, the same for second part. Okay, let me do with one more pod. The same command, maybe using the fourth one. Okay, let me go inside this pod. We are inside this pod again. Echo pod 2, and then we are going inside this file. Cool. Now access service multiple times. Okay, let's see. Let's access our service. Welcome to nginx. So again, let's do it again. Let's do it again. do it again. Let's do it again. Okay. I don't see any changes in the IP. What it is trying to say. Let's see. You should see alternating part 1, part 2, part 1, part 2. Somewhere I made some mistake. If it is saying uses here .html, let's open this file, otherwise we will not understand. There is nothing inside this file. Refresh browser repeatedly. Okay, cool, got it. We need to read the instructions very carefully. It is saying refresh the browser repeatedly. So, what will happen? We will see pod 1. Okay, pod 1. It is still routed to pod 1. It is still routed to pod 1. Pod 1. Nothing on pod 2. Everything is on pod 1. Every time it is routing to pod 1, I don't know why it is not routing to pod 2. Pod 1, it is not writing, not routing properly. We went inside a pod with execute command. We saw the pods, okay? We just share nginx and then HTML index. Okay. Let me try one more time, maybe. First of all, let me execute this command. We execute this pod, and then I need to give a pod name, right? So this time I want to give my fifth pod, this pod, a chance to get routed. Cool. We entered in the fifth pod right now. This ZQ7 to Z, and inside this pod, what we can see, we need to run this echo pod too. Since we are inside, okay, echo pod 2. So echo pod 5, right? We are inside the echo pod 5. Then its contents we need to concatenate into this file, nginx file. Awesome. And then we exit. Cool. Now let's run this service command again. Minikube service and nginx service. Let's see if something is happening. Let's refresh pod 1, pod 1, pod 1, pod 1, pod 1, pod 1, pod 1. it is not refreshing to port 2, port 3, port 4, something like that. Uh, 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 we are not seeing alternative values. Okay, let's move ahead. Maybe we will get time and understand this. Why it is happening. It is saying how load balancing works internally, like client calls and then it goes to the node port service, then IP tables. There is a queue proxy. Okay, queue proxy does the IP tables. Okay, there is IP all the table. There is a table with all the IPs. One of the ports round robin is used. It uses IP tables rule inside the node. Okay, but in our case, we did not get the chance. We were not able to route, right? Every time we were getting our routing is odd one only. Okay, I think this routing is done. Okay, okay. Now let's go to the second part, rolling update demo. Now we simulate real production deployment. Update image version. Set image deployment engine is equal to 1.25. So what we have Nginx version in the deployment file to be, I think it is one right now. Okay, okay, it is deployment apply version is a V1, right? What it is suggesting, qctl set image deployment 1.5. Okay, let's see this deploy nginx image updated. Okay, now watch rollout kubectl rollout status deployment. Let's see and run this command and let's see waiting for the engine deployment rollout to finish 3 out of 5 new replicas updated. Okay, 3 out of the 5. So let's see the service command, right? Let's see if our parts are get all the parts. Not, so let's run this one somewhere maybe here. Alright, it is not taken. Somewhere some problem. Let me see. Okay, so till now here you can see status also. Meanwhile, it is updating. I We are seeing the parts like these four are running. One is terminating, one is container creating, and then one is completed here. Okay, and here you can see what is going on. Basically, we set our image was updated, then we are looking into the rollout status. So this rollout status of the deployment, the new version actually. So waiting for the deployment, rollout to finish 3 out of 5 new providers and 4 out of 5 to old replicas are terminating, pending termination. Okay, 4 out of 5. Okay, so here again, here you can see this is the running. Let me see here what is the status right now. Okay, all are running right now, everything is fine. So this was the important thing. While the rolling update was going on, you can see some of the parts are already running while no one is terminating. So rolling update is basically bit by bit update. Okay, not all will stop and then all not all parts will be recreated or restarted with a new one, but already running would not get any change. So they are already running, and what is happening here, it is basically terminating, then creating the new container, and then basically it is running, it comes into running status was completed. Cool. And we can see here IP is deleted. Actually WRQ5Z was earlier. Let's see if this was, which one is new, this WRQ5Z is new, or this one is new, or this one is new, and our older, these are older one or new one. Okay, let's compare. Hello Moto. What is happening here is you can see what you can see is, one second. Let me run the command again. Actually we need not to run, we need to compile, right? So we need our old replicas. Yeah, so these are the old replicas and these are the new ones. Hello Moto. Hello Moto. How can I compare? Every time when I'm switching tabs, it is actually getting lost. Okay, so these were the stations, right? So here you can see the name 2R45. Just remember 27SVZ. Just remember these values. We will see in the pod, and we will answer, because I am not able to switch very fast. 27SVZ. Just remember the first letter 27SVZ. 27SVZ. This should be the pattern, right? 27SVZ. So here it should be 27SVZ. It is not 27SVZ. All are new. All are new. 27SVZ. Nothing is here. B is here. 2 is here. S is not here. V is not here. Z is not here. Okay, so only two are old one, right? These are terminated. Okay, so all are new actually. It doesn't seem to be the similar to the old one, because new names are here: N2, M5, CP, 4B, WR. Okay, it's okay. No problem. Let's run it again. It's okay. All are new actually. It's probably okay. Now this is same. So old are terminated and new parts are actually deployed. New pod created, new pod becomes ready, old pod terminated, repeat. Our old pods are terminated. So this is important. Actually, we can see our all old pods are terminated. They are not here. Actually, old pods have different name. Actually, this one, 27, this is all the old pods are deleted. So we can see the IP also, like IP is 11. IP of our old pods is 11, 10, 9, 13, 16. Is the IP same or it is new? So if it is deleted, it should be different, right? Yeah, here you can see it is 17, 18, 19, 20, 21. Yeah, so all the old pods are deleted and slowly new pods are created and all are running. So there is no downtime basically. So important thing is like this phase, this command rollout status deployment. So rollout status we can check and it is saying like 3 rollout to finish 3 out of 4 and 4 out of 4 2 will replicas then 1 other pending termination. Basically all are terminated and new parts are created. So I think this is good. This is rolling update. So it happened internally all replicas set जो थे Nginx select ना they come to the new version Nginx 1.25. Then gradually increase new RS replica, decrease old replicas. Okay. So in YML we can give strategy equal to rolling update, max available 25%, max of 25%. So if we will give this one, then it is the default value. So basically it will automatically after some time it will create new pods. And then step 3, if something breaks, we can roll out back to the previous version. So let's see if we can go to the previous version. It is good. We want to roll out our previous one. Okay, this is rolled back. So now we should get our old values, right? So okay, it is still terminating. Let's run this command once again. This one. Here you can see. Okay, all are running now. So this is important. Here we can see all the terminating parts and then running parts and this one. Okay, let's run this command actually. Status deployment. It will also be oh, all are successfully rolled out. You missed the chance. Okay. Let's see the parts now. All are old or not. Okay, it is saying it is rolled back, but with new IPs are created like 22, 23, 24, 25, 26. So new parts are created. It is uh, deployed, sorry, rolled back, but new parts. I think naming is different. They are not similar to the our very old parts. 77, 77 and 8P is W. So it is not similar to that, I think. 712, 7QHJ, VZZQ, yeah, it is different than our old one. Okay, so it is rollback, but new IPs are there. It is not similar to that. Move back to previous version. This is where, how can we see the version? Okay, let's see. We will see like how to see the previous versions after rollback. And rollback we have zero downtime, control rollout. This is zero downtime. Easy rollback, traffic automatically handled by service. Awesome. So what we see, we covered self-healing, load balancing, rolling updates. Cool. Okay. Replica set deep dive, config map, secret, deploy springboard, negative dive, no HP auto scaling. Okay, so it is saying you are progressing fast, so we can stop live for today. I think this is great. Thank you for being with me. Uh, let let's see how this versioning is working. Like it is important. After that, we will go back. Okay, so here see what is replica set. So replica set is a Kubernetes controller that ensures exactly n parts of the matching template must exist. Okay, it does not care about versions. It only cares about template, replica count, and labels. So in the deployments file, if you can see here, there is replicas file. So basically, it focuses on the number of parts, then labels, what are the labels, and then our template. So here it is the template actually. Deployment replica set and parts. So when you create a deployment, there is a relationship like when you create a deployment, Kubernetes internally create a deployment, then replica set, then parts running. You do not create relation manually, deployment creates automatically. So when you run this one, what happened in the deployment? We already run this. So let's run this once again. Okay, deployment is updated. Now it is updating with the new. Again, it is updating, right? So here we can see the status. All IPs 25, 26, these all are running. All template in units, new template in profile. Since port template change, Kubernetes creates new replica set. Okay, so it will create old image, new replica set here. So we are having old image and new image. Basically, we can see here it is creating the containers. Some are running, some are completed. After some time, it all will be running, right? Yeah. So all are running now with new IPs. Here it was 22, 23, or something like that. New IPs are provided to all the pods. So let's run it. kubectl rs. Okay. So what we are getting replica sets. It is saying kubectl get replica sets. So here you can see we have 5 replica sets. All right. Ready, running. Okay, so let me run the version again, then this command, so that we can see which are ready, which are not desired, something like that. So let's run this command, then get rs. Okay, it is maybe first all are running. Okay, so here you can see desired is 5, current is 5, ready is 5, everything is 5. Okay, so here we can see 5 replica sets. In this example it is 2, but we have 5, right? 1 scale to 0, old version. So this is the old one. All the replica sets kind of all are deleted, right? And 1 active, this is new version. 1 active, which is new version on the 5 sets. Okay, awesome, awesome. This is the version history. So how, one question is how what replicas are name is generated. So that suffices a hash of the part template. If template changes, image is now uses a hash changing. This creates a new replica. So basically it is a hash of the template. This is how you track versions. Now we can cover what happens during building update. Let's assume replica set have two building update strategy max at 25, max unavailable is 25. Okay, two things are there, max surge and max unavailable. In that case, we need to cover. So for 2 replicas, it is saying it creates 1 extra pod, surge, waits until it is ready, deletes 1 old pod, then repeats. This is the process. Like there is surge, So if there are two pods, it will create one pod with one replica. It will create one extra pod, and then it will wait until it is ready, then delete one pod and then repeat. So traffic is never dropped. Awesome. What a beauty. So you remember this file HTML.index file fitting. So what we did when we call that service multiple times, UCTL after running this command, you modify the file system of that specific container only inside that part. Replica set important is replica set does not track runtime file changes. Okay, only tracks pod template definition, image, and config. Pod die new pod is created from the original image. Permanent file changes disappears because pods are ephemeral. Ephemeral means they can die. This is a huge protection concept. Containers are immutable infrastructure. You never SSH into container. Modify. You cannot SSH into container. Modify files manually. Patch running container. So it is immutable infrastructure containers. You never SSH to container. Modify files manually. Patch running container because replica set recreates from image. Your changes vanish. Third way is build a new image, update the deployment, rolling update happens. Now let's enter the facility because it is described inside. Okay, let's dive deeper into the replica sets. Okay. Replica set we have this one is running right. Uh, so what is there? Cool. We come here. We see the namespace, everything, label, annotation, control by replicas 5 current running. All are running. Good. 0 failed. Then nginx okay. Sector events. Yeah. Here earlier events was empty. Earlier it was empty. Now we can see events type reason is from message. Created pod replica set controller from replica center. Okay, successfully create everything is good. So these are the events which happen inside the container. Control by, you can see control by. So where is control by? This is the controller message created box. So we are not able to see controlled by. Okay, this here it is a develop deployment stress minus deployment. It is the control by. That post deployment was owns replica set. So replica sets are controlled by deployment. When you run this one, deployment simply scales all replica set up, scales new replica set up. Okay, when we roll out, basically just okay. Okay, no magic, just replica set. Let's see the full diagram, life cycle diagram. Initial state deployment, replica set are created. We have 5 pods. Okay, after updating, here in example 2, but we have 5 pods. We have 5 pods. These are 5 pods. And now after update, deployment replica set is scaled down to 0, which we saw. It is talking about this one, like it is 0, old one, and these are the new ones. Rollback happens, A scales up again, and B scales down. So if we run rollback, we can see let's run back. Let's run back, okay, and then we will run this command again. Get us. Not this one. Let's roll back. Okay, it is rolled back. Now let's get the replica sets. Okay, so here you can see it is in progress. Alright, it is just in progress. Now we can see we can use this command and we can see okay, everything is up and running, so we cannot see. Let's run our get rs again. Okay. So here now look closely what happened here. Where is that? Our old and new one. Where are they? Not this one. Okay, see this. Nginx here only 0. This is the this was the new one, right? Here it is shifting. Some of them are ready, some of them are not. Before that, I want to show you 0 0 where the status was actually. This one I wanted to show. This. So here you can say this was the new one. Earlier it was new one and this was old one. Okay. When we did the rollback, then this 84B, look at the 84B, it is was active one, and these all were old ones. Old one are kind of shifted to new one. So new pods are created, and there is the up and running five pods. Okay, five replicas. Now for let's see for this 84B and C74. 84B C74. Remember the name. 84B C74. When we use rollout, basically when we did this command, run this command rollout, then what happens? Some of them are basically moving. You can see moving. Okay. After moving, you can see this 84B now all here desired everything was 555 and this was 0 0 0, but again it rolled back to 0, basically 555. So old status right now. Everything, all the new parts are dead now, old now, and older are up and running again. So this is good, I think. Okay, let's dive deeper. Let's dive into an interview level question, which is saying if you asks why not give replica sets directly. So answer is like replica set does not manage version history, no rolling update logic, no rolling deployment, and it's high level orchestration. So we will not go into this. I think for today, till here it is about like how rolling basically happens. What is how rollback mechanism works in Kubernetes. So we covered a lot. I think that was great actually. Okay, so let's stop. Thank you guys for here on the report. We will meet again.